Welcome to part 6 of our video series on estimation. In this video, we are going to discuss binary data and the mode as a descriptive statistic. We're going to talk about proportions. A proportion is a parameter, of course, which has a point estimate. We're going to talk about what is a Bernoulli trial. And finally, we're going to talk about the binomial distribution and a distribution that's often used to approximate it. I'm Renee Clark from the Swanson School of Engineering at the University of Pittsburgh. Okay, so let's first talk about binary data. Okay, now binary data is qualitative data or categorical data. Okay, remember from earlier in our videos, we talked about quantitative versus qualitative data. Okay, so binary data is qualitative. Okay, so it's a binary variable can take on only one of two possible categories or values. So for example, a part that's made in a factory is either defective or it's not defective. Or a COVID test is either positive or it's negative. Or an offer may be extended or not extended to a particular candidate. Okay. Binary data is also known as dichotomous data, in case you hear that term. Okay, so let's look at the bar graph on the right. And let's say this is the result of offers that have been extended or not to graduate school applicants. Okay, and as you can see, that more offers were not extended than extended, okay, because it looks like there were about 65 offers that were not extended versus, say, around 35 that were. Okay, so in this case, and this was a binary variable, but no is what we call the mode, okay? Or another way to say that is the modal category, modal. Modal just means the category having the greatest count. In this case, it's no, okay? The mode is a type of descriptive statistic for categorical data, okay? Highly useful for categorical data, so you can keep that in mind, okay? Now, binary or dichotomous data is the opposite of polytomous data. Okay, polytomous data simply means that it is a qualitative variable that has more than two categories, so poly. Okay, proportions and Bernoulli trials. Okay, the population proportion, which is a parameter, is labeled with the letter P. Okay, so some examples of population proportions might be the proportion of all cars in Pittsburgh that are blue, okay, or the proportion of all items made at a factory that are defective, okay. So P as a proportion or as a parameter, we have to estimate it, right? So an estimate of P comes from what are known as Bernoulli trials, and in particular, N of them, okay? And these series of trials form what's known as a Bernoulli process, okay? So a Bernoulli trial, then, is an experiment, or if you want to think of it as a variable, that can be classified in one of two ways. Okay, sounds familiar, we just talked about this. So for example, yes or no, success or failure, defective or not defective, okay? So in essence, it's a binary variable, right? One of two ways. Okay, so an estimate or a point estimator for the population proportion is given by P hat, okay? So the little symbol here over top the P, that's hat. And when we use a hat, that just means estimate, okay? So P hat, or the estimate of P, is given by Y over N. So what's Y and what's N? Okay, that's on the next. Okay, so in the numerator, we have y. Okay, y is a count variable, and specifically, it represents a count of your successes in those n Bernoulli trials. Okay, now, when we say success, what we mean is think of it as the characteristic that you're interested in counting. It doesn't necessarily have to be a desirable characteristic. So for example, perhaps we are interested in counting the number of negative COVID tests, right, which isn't necessarily a desirable or a successful outcome. But again, the word success here simply means the characteristic you're interested in counting, whether that is desirable or not. Okay, in the denominator, we have n, which represents the number of Bernoulli trials, okay, or also known as your sample size. Okay, so in the numerator, y, okay, we said it's a count variable. It's distributed according to the binomial distribution, okay, and as we said, it's a count variable. You can also think of it as the sum of your 0 or 1 outcomes from your n Bernoulli trials. Okay, and remember, each Bernoulli trial is like a binary variable. Okay, and so that value of 1, it can only take one of two values, but that value of 1 corresponds to your success, right? Or the characteristic that you're interested in counting. Okay, now there's actually a distribution that we've gotten very familiar in working with that is often used to approximate the binomial distribution. Okay, that distribution is the normal distribution. Okay. And we can do this approximation if the following two conditions hold. The first is that your sample size or number of trials times the population proportion of success must be greater than or equal to 5. Okay. The second condition is that number of trials times 1 minus p, or your population proportion of success, also greater than or equal to 5. So this is actually your population proportion of failure, right? Now, when we are going to test, when we want to test out this particular assumption, since we don't know p, we will substitute in p hat for that we are able to approximate using that equation, okay? But the normal distribution is often used as an approximator because it's easier to determine probability values using the tables in the back of the book. Okay. We wish to thank the National Science Foundation under Grant 233-5802 for supporting our work. Thank you for watching.